Hi guys. So we have this problem with us. Let's see how we can break it down. So the question reads: Find the values of sine theta and tan theta given that cos. We're supposed to have cos theta. Given that cos theta is equals to 5/6, and this is in the first quadrant, and also theta in the fourth quadrant. So first of all, we know that cos theta is equals to the adjacent over the hypotenuse. Also, sine theta is equals to the opposite over the hypotenuse. And lastly, tan theta is equals to the opposite over the adjacent. Okay, so this we know. Now, since we have cos, this simply means that cos is 5/6. So because of this, our adjacent is 5 and our hypotenuse is 6. So what we need is the opposite. Adjacent is 5. So here we have adjacent. You can already put the 5 in advance. The hypotenuse is 6. So here we have hypotenuse, we will put the 6 like that. Now, to find the opposite, we're going to do this. We know that if I have this right-angled triangle, this here, we do this. This is my theta. This will be my opposite, and in this case, the opposite is what we're looking for. So let me just use x. This is our adjacent, in which our adjacent we said our adjacent is 5, and our hypotenuse is 6. So to find the value of x, we're going to say, according to the Pythagoras, x squared, which is the opposite, plus 5 squared, the adjacent, is equals to 6 squared. So this should give us x squared is equals to 6 squared minus 5 squared. So x squared is 36 minus 25. So x squared is equals to, this should give us a 9. Hence, the value of x is simply equals to 3. So we have our opposite is 3. So if that's the case, this simply means that sine is opposite over hypotenuse, hence we have a 3. Then tan is opposite over adjacent, so we'll put a 3 there. But we're not done, because there's a condition which says that for theta in the first quadrant. So this is what I want to do. Let's draw the quadrants and the two triangles of interest. So in the first quadrant, the triangle will be this one like this, with a component in the x and a component in the y. So this here is the opposite. Sorry, this is the adjacent, and this is the hypotenuse. So since this is the opposite, rather, this is the hypotenuse, this is adjacent. So this here is our 3, the opposite. This is our adjacent, which is 5. This is our hypotenuse, which is 6. Like that. From there, we also need it in the fourth quadrant. So in the fourth quadrant, we're going to do it like this. We just extend it a bit. Another one down like this. So this is the fourth quadrant. So in the fourth quadrant, this is our adjacent. Remember, theta is here. This is the adjacent. This is the opposite. So this is our 3, and this is our 6. So the only difference that we're going to apply here is this. We're done with this. Let's move it. The only difference that we'll have between the two is that in the first quadrant, for question A, remember everything in the first quadrant is positive. So for question A, we'll take it as it is. So we need sine. So sine theta is opposite 3 over hypotenuse, which is 6. For tan, it's also positive. So tan theta is equals to the opposite over the adjacent, which is 5. We're done for quadrant 1. So I'll say this is for part A. For quadrant 4, which is part B in this case, we can see that the opposite is going down, hence it's negative. The hypotenuse is the resultant, so it will be positive. So for this particular one, for sine, we shall say sine theta is equals to a negative 3 over 6. Remember, in the fourth quadrant, sine is negative. Same thing for tan. For tan, we'll have tan theta is also equals to negative 3 over 5. Simply because tan in the fourth quadrant is also negative. So there we have it. Thank you very much.